So I'm going to do number 1, and the first thing you do is take the derivative. So the derivative, or y prime, would equal negative 3x squared plus 4x. So you'd factor out a negative x, which would make it negative x times 3x minus 4. Now you take this equation and solve for x, the x coordinates. So the first x coordinate would be 0 for the first part, and 4/3 for the second part. So now what you want to do is plot it on a number line. So this would be 0, and if this is negative 1, and this is 1, then 4/3 would be around here. Okay, so now we have to choose the other part of the interval, or the number that we're going to put into the derivative up here. So let's choose negative 1, 1, and 2. So first thing you want to do is plug in negative 1. So we're just looking for the sign, so I'm going to try and do this fast in my head. So if we plug it into the first section, it'd be a positive. If we plug it into the second one, it'd be a negative. A negative times a positive is a negative. Okay. For the second interval, it would be, let's see, 1, the first part would be a negative, and the second part would still be a negative. So negative times a negative is a positive. And then the last sign that we're looking for, we plug in 2, so the first part will be a negative, and the second part will be a positive. So positive plus the negative equals negative. So now what we do is we use this number line right here to find the open intervals where the function is increasing and decreasing. So right here, it's increasing at the points, or the intervals. Let's see. Increasing is the positives, so it's increasing at 0 to 4/3. And it's decreasing at the intervals negative infinity to 0 and 4/3 to positive infinity. So that's how you figure out for those. And I don't exactly remember how to solve for discontinuities, but I do know that this one is continuous. So these are the answers for number 1. So I'm going to do number 3 as the hardest one that I can't really finish. So I'm going to take the derivative, which would be negative 4x to the third plus 6x, and then you factor out negative 2x, which would make it negative 2x times 2x squared minus 3. Okay, so now we solve for the x's. So the first x coordinate would equal 0, and the second x coordinate would equal, let's see, 3. It would be 2x squared equals 3 divided by 2, and then the square root of that would make it the square root plus or minus square root of 3/2. Okay, so let me just erase this for more room. Let's see. 1 second. Okay, so now that we have these two x coordinates, we have to plot the points. So the points would be 0 in the middle, so this would be 0. And if this is 1 and this is negative 1, then hold on, let me figure out what the square root of 3/2 is. Okay, so it would be 1.2, which would be right around here. So this would be positive square root of the 3/2, and this would be right here, the negative square root of 3/2. So to choose the numbers, I would choose 2, -1, 1, and 2. Oh, sorry, this is -2. So now that I plug it in, the first sign would be a positive for this one, and the second sign would be a positive, another positive. So positive times positive is a positive. For the second one, -1, you plug that in, the first sign will be positive, and the second sign will be a negative. Negative times a positive is a negative. For 1, the first sign would be a negative, and then the second sign would be another negative, which would make it a positive. And then the last one would be another negative, and then it would also be a positive. So negative times a positive equals negative. So using this, I could say that it is increasing at the intervals negative infinity to a negative square root of 3/2 and 0 to square root of 3/2. And I can say that it's decreasing at the intervals negative square root of 3/2 to 0 and square root of 3/2 to infinity. So that's the answer I got, but when I checked it with your answer, it wasn't right. So that's where I got stuck. And I still don't know how to determine if it's continuous or not, but I know for sure this one's continuous. Okay, that's it.